This is a very challenging amount of substance redox titration question. We're told we've got this iron sulfate, hydrated iron sulfate. We're told it's impure. And then we're told like they do a titration and we've got to work out a mass value. Now the mass value we're going to work out cannot be the correct value because we don't know what the impurity is. But we can work out a value for mass if we imagine that it is pure. And that's what it wants us to do in this question. Okay, so let's draw out the sort of what's happening. What we're doing is we've got our hydrated iron sulfate, and that's going to be like in a conical flask. So in here, we're going to have our iron sulfate. Okay, now what information do we know about this? Well, we know that it's made up to 250, and then it's 225 of it is put into this conical flask. So actually, this has been from a standard solution. So this was probably made up in a volumetric flask, one of those flasks with the long neck. Okay, so we originally had 250 of it, and then we've got 25. Cn cubed. Then a titration was done. So we got a burette, and in the burette, the chemical in the burette is the potassium dichromate, which is our oxidizing agent. So it's going to react with the iron in the hydrated iron sulfate. It's going to oxidize the iron. So what's going to happen to the iron is the iron is currently, you can see if you work out its oxidation state, you should be able to see it's in its 2+ state. And it's going to get oxidized into its 3+ state. Okay. We'll need to work out the equation for this. And the way we're going to work it out is we'll look at the half equations, then match them up for our electrons. So let's do the half equation for the chromate ion. Let's do that in blue. So here is my potassium dichromate, or I'm going to forget about the potassium part because the potassium is just like a spectator ion. So there's the dichromate ion. And you should be able to work out that the chromium is in its +6 state. Let's just check that out. 7 times 2 is 14, and then another 2. So that's 6. Yes, no, sorry. So oxygen is -2. There's 7 of that, so that's -14, but the charge is -2, so that takes off 2 of that, so it's going to be -6. Therefore, each chromium is +6. Okay, and that's going to turn into chromium 3+. And that each chromium is gaining 3 electrons, so a total of 6 electrons. And then we just need to balance that with water and whatever, but that's sort of irrelevant. The important thing is we know the electrons, because then we can use that to work out the ratio. So 7 waters, and then we need a lot of hydrogen. It's going to be +14H+ to balance the hydrogen in the water. Okay, that looks right. Okay, what's important though is the fact that it's 6 electrons and that's 1 electron. Okay, so now we know because this one is giving up 1 electron, that one's requiring 6. We now know the ratio between these 2 equations is going to be 6:1. Let me write those 2 equations out so we know we can times this one by 6, because this needs 6 electrons. This is only giving up 1. So if we times everything by 6, now this is giving up 6 electrons. That's needing 6 electrons. So we can write both equations now. Let's do it. Here's the 6 iron 2+. And then we've got plus the 14H+. The electrons are going to cancel out, so I won't bother drawing them because there's 6 electrons there, 6 electrons there. We've got the dichromate ion. It's going to form 2 chromium 3+. 7H2O. Okay. Now we've got the balanced equation, we can now start doing some maths. So we can work out the moles of potassium dichromate. We're given the volume, we're given the volume and the concentration. So we can work out the moles of potassium dichromate. Oops, I forgot the charge. And that's going to equal moles equals concentration times volume. Concentration is there, 0.015. Volume, 21.3 over 1,000. Let's put it in a calculator and get some moles. So it comes out to 3.195 times 10 to the minus 4. That's moles. Okay, we want to know how many ions there are though. So we can see the ratio to chromate to iron is 1 to 6. So therefore, moles of iron 2 plus is going to equal this number times 6. Let's times that to the ratio, 1 to 6. Comes out as 1.917 times 10 to the minus 3. Now, we need to work out mass of the whole substance. Well, the iron 2 plus, how many iron 2 pluses are in hydrated iron sulfate? 1. So therefore that value there is also the value for the moles for the hydrated iron sulfate. So to work out the mass, I just need to take that value there. Mass equals Mr. Moles. This is mass of the whole thing. Mr. Moles. So I know the moles is there. Just need the MR, Mr. So let's work out the MR. So we got iron. Iron is 55.8. Sulfur is 32.1. And we've got 4 oxygens, so 4 times 16. And then we got 7 waters, so 7 times 18. So I make that 2779. 2779 for the MR times the moles. Remember the moles, the ratio, how many iron 2 pluses are in hydrated iron sulfate? Well, 1 to 1. So the mole value is the same. So it comes out to 0.532. Now, of course, this mass is the mass that is in 25 cm cubed. So actually, probably what I should have done is done this conversion earlier. I should have times this mole value by 10. I can just times, because actually what it wants us to work out the mass in 250. So you can see there's a difference here. We've just worked out the mass in the 25 conical flask, but we want to know the mass in the 250 volumetric flask. So it's just that mass times by 10, which I can do now, or I could have done with the moles. So let's times it by 10. So I get 5.327 grams. And I think because all the numbers there are to free SF, I'll round my final answer to free SF, although it doesn't actually matter because the question hasn't asked. So that's fine. Okay, now the next part of the question wants us to look at, where are we up to? Oh, here it is. It wants us to. It says the student found that the calculated mass was actually greater than the actual mass of the sample weighed out. Let's think what that means. So the student found that the calculated mass, that's the one we just calculated, 5.33, is actually greater than the mass weighed out. So that means that the student maybe weighed out 4 grams. but we've just calculated that it's 5.33 grams. So it doesn't make any sense. Well, it tells us initially there's an impurity. So you weigh out 4 grams, but there's an impurity which must be reacting as well with the potassium dichromate to make us think that there's actually 5.33 grams. So what property must that impurity have? Well, it must react with the potassium dichromate, and it must react in a ratio which is more than or showing that more moles of potassium dichromate react than the iron 2 plus. So basically something like maybe vanadium 1 plus, which actually gives out more electrons. So to answer this last one, we need to talk about the fact that the impurity must react with potassium dichromate, therefore is a reducing agent, and actually must react more, so it must give out more electrons than the iron 2 plus.